Alright, hi everyone. Let's continue with our data structures and algorithm series. In today's video, we are going to see a very common searching algorithm, and that is linear search. Linear search is a simple searching algorithm that checks each element in a list one by one until the target value is found. For example, as you can see, I have a list of integers here 7, 10, 12, 15, 19 and 20. And now if I ask you to find 12 in this list, then probably you might be finding it like comparing 12 with first element, then comparing it with second element, and then comparing it with the third element. And here you have found your target value, right? And linear search also works in the same manner. It keeps on checking all the elements of the list until we found our target value. I have an example problem statement here. Let's try to solve this by writing code in our code sandbox. You are given an array of unsorted n integers and a target integer. Try to find the target in the array. If the target is found, return its index. Alright, so the problem statement is pretty simple. Now to find the target, first we need to compare our target value with all the elements in our given array. For that we will need a loop here. This for loop will run from 0th index to the last index of our given array. Now we need to compare all the elements with our target value. Once we find out our target, we need to return its index. In case we are not able to find our target value, then we will return -1. Alright, that's all what we need to do. Now let's try to run this code and see if we are getting an expected output or not. As you can see, we are getting the index value as 2, and that is correct because on our 0th index we have 11, on first index we have 1, and on second index we have 6. That is our target value. Now what if I use this example? Now you can see we do not have our target value in the given array and it returns -1. So our linear search algorithm is working as expected. Now if I ask you to find the time complexity of our linear search algorithm, then for best cases it will be O of 1. How exactly? Let's see. If I ask you to find 32 in this array, then your iteration will only run once, right? Because your target value is present at the very beginning and we don't need to iterate over the rest of the elements. So this is our best case. In average case, it will be O of n. Now if I ask you to find out 10 in this example, then your iteration will run for n number of times, right? Because you have to compare all of the elements and in the end you will find your target value. In worst case, the time complexity will remain O of n here. Worst case can be if I ask you to find out 0 in this array, which is not even present, but you are still running from first element to the last element. Now this array can have large number of elements and comparing each element is not an ideal solution. That will make our time complexity as O of n. Space complexity will remain O of 1 here because we are not creating any new array or storing any data in the given array, right? Now let's look at some of the inbuilt array methods that are using linear search behind the scene. As you already know about, .indexOf is a method that returns the index of first occurrence of the element. If that element does not exist, then it will simply return -1. If you see in this array, the index of 30 is 2, right? And this method runs linear search behind the scene to find out the index. We also have .includes method that checks if the element exists in an array or not. For example, in this array, you can see we are trying to find if 10 exists or not. If it exists, this method will return true, otherwise it will return false. And this method also uses linear search behind the scene. We also have .find and .findIndex methods. .find method basically returns the first element that satisfies our condition. In this example, you can see if number is greater than 4, then return the number, and the first occurrence is 5. This method also uses linear search behind the scene. Same with findIndex, but findIndex returns index value instead of the target value. Now, since we know these methods are using linear search behind the scene, we can use them according to our use case, because we know the time complexity can go O of n in worst cases. If we have to solve a complex problem, then we might not be in the favor of using these methods. Alright, so that's all for this one. In the upcoming video, we are going to see another search algorithm, that is binary search, and we will see how it can improve the time complexity in comparison to the linear search. And thanks for watching.